Hello friends, welcome back. And after a long time, we are starting our session. And from today onwards, we will discuss about the relay testing procedure and relay testing using Omicron Relay Test Kit. In this session, we will focus on the testing of differential protection relays, followed by REF and directional overcurrent and earth fault protection in the upcoming session. I'm not going to get into details about the basic concepts of ICT differential protection relays. What are the meaning of different settings, as these are already covered in one separate session. In this session, we will focus specifically on the differential relay testing procedure. These slides are prepared using RET670 differential relay, but the procedure explained herein are applicable for all, that is Siemens make relays, Alstom make relays, GE make relays, or any other differential relays. The procedure will remain exactly the same with only slight differences related to the settings of particular make of relays. Now, without wasting any time, let us start with today's topic, and I will focus in this session on the differential relay testing. For this particular session, we have considered one 315 MVA ICT with 400 by 220 kV rating. That is, the HV side is 400 kV and IV or LV side is 220 kV. Transformer impedance is considered as 12.5% and CT ratio of HV and IV side is 1000 and 1600 ampere respectively. Now, as you know, the current of HV side can be calculated by simply using this MVA divided by root 3 into voltage of this side winding, that is 400. Since this is in MVA, so this will be 10 to the power 6, and this is kV, that is 10 to the power 3, so this will be 10 to the power 3, and this, if you calculate, it will come out approximately 455 ampere. Similarly, for I of LV side, you can calculate by the same method, and it will come approximately 826 ampere. So the current of HP side is 455 ampere for this particular ICT, and current of LV side is 826 ampere. And remember, these are in the primary. So the secondary will be IHV secondary will be 455 divided by 1000, that is 455 milliampere. And similarly, you can calculate the ILV secondary, and this will comes out to be 826 divided by 1600, which is 516 milliamp. So the next thing is how to connect your Omicron relay test kit to your differential relays. So for that purpose, you have to check your scheme drawing, and here I have considered one simple schematic drawing in which you can see there is this CT from HV side, this is CT from LV side. The CT from HV side is connected to X011234 and CT from LV side is connected to X016789. So if you connect your Omicron relay test kit, the Omicron relay test kit, suppose this is the current channel, suppose this is channel A, this is channel B current, and this is your R phase, Y phase, B and neutral. Similarly for channel B also R, Y, B neutral. Just connect this R, Y, B neutral to this set, that is HV, and similarly channel B to LV. Now, if you see, this is the TRM module of RET670 relay. There are current channels like this A, B, C, or R phase, Y phase, B phase of suppose HV side. So if you see here, this is the current entering to R phase. The second side of this R phase, it is connected to Y, this is connected to B, and it will form the neutral, and this is your neutral wire. Similarly, this is Y phase and B phase. This is for HV side, and similarly for LV side also. So this is applicable when you are reading your drawing, and this is depending upon which relay you are using. The schematic drawing you have to refer for that particular relays only, and you have to make the connection as per the schematic drawing available with you. So now the first thing that we check is the stability of differential relay. What is the meaning of stability? Stability means when you inject the normal rated current on the HV and the LV winding of the transformer with correct polarity, then your relay must remain stable and it should not issue any trip command. So now what is the next step that we have to follow is, if you see here, there are three voltage channels VL1, L2, L3, and we don't need this for differential relay testing. Then we have three current channels L1, L2, L3, and the second set of current channels, that is I1, 1, 2, and 3. So now, firstly, I will have to inject the current for the HV side winding. Now, as I have already calculated, the HV side rated current is 455 milliampere for R phase, Y phase, B phase, and the angle will be 0 for R phase, minus 120 and plus 120. If you see here, this is your R phase, Y phase, B phase, 0 degree, minus 120 degree and plus 120 degree. Similarly, for LV winding, the current will be 826 divided by 1600, that is 516 milliampere. And if you can see here, this is your suppose transformer, then the current, suppose this is your HV winding, this side your LV winding connected. So the current, it is, if it is entering the object, this is leaving the object. That means if it is at 0 degree angle, it must be at 180 degree angle. So that's why I have started this as 180 degree. And then if you select balance, it will be automatically 180 minus 120, that is 60 degree, and 180 plus 120, that is 300 degree. Now, if I inject this current in R phase, Y phase, B phase of HV winding and LV winding, and if the connection is correct, if the CT polarity is correct, then relay must remain stable and it should not issue any trip command. Remember, the frequency that I am injecting here is 50 Hertz. Now, just reverse the connection of any one side. So for that matter, suppose I am reversing this from 180 degree to 0 degree. So in next slide, you can see here. Now this is 0 degree, and similarly this will be now minus 120 plus 120, and this is the HV side winding. This I have not reversed, so this is exactly the same. HV side is same. I have not reversed here. So if you reverse this, then what does it mean? It means that if this current is entering the object, this current is also entering the object. That means there is definitely some fault inside the protected object or inside this transformer. And so your relay must issue a trip command. So once you reverse this direction, definitely my relay will issue trip command, and that trip command will be instantaneous. Now, the next thing is how to check the differential relay pickup setting. So, for this, suppose the differential current pickup in my relay setting or inside the relay is 0.2 times of I base. So, first of all, you have to calculate I base. So, now this is a 400 by 220 kV. So, this is HV side, which is 400 kV, LV side, which is 220 kV, ICT of 315 MVA. That means the current I base of this side will be 455 ampere. This will be your 826 ampere. Now for secondary, this I base secondary, it will be 455 divided by 1000, that is 455 milliampere, and this will be 826 divided by 1600, that is 516 milliampere. So this is my I base. And what is my differential minimum differential current pickup ID minimum? This is 0.2. So what is ID minimum? ID minimum will be 0.2 into 455, and for this side 0.2 into 516. So it will be 91 milliampere and 103 milliampere respectively for HV and LV side. So what is restricted here is simply this is your 455 into 0.2, that is 91 milliampere. So this is for HV side. And now if I inject the current which is above this 91 milliampere, definitely relay will issue a trip command, and that trip command must be instantaneous. Now one thing that you must consider here is whether the zero sequence filtering is on or not. I have already covered in detail about the zero sequence filtering in the differential relay video. So you can see there what is the meaning of this. But if this zero sequence filtering is on, then your single phase pickup and three phase pickup will not remain the same. So this 91 milliampere, it is your three phase pickup. So single phase pickup will be 1.5 times of this, and it will be something approximately of 135 or 136 milliampere for HV side. If the zero sequence filtering is on, if your zero sequence filtering is off, then the three phase and single phase pickup for both uh, HV side and LV side, three phase pickup will be same as single phase pickup. Now, how to check this three phase or single phase pickup? So, if you want to check the single phase pickup of HV side, just inject the current in R phase. Now, you see here, all other currents are zero. Now, starts increasing the current with 1 milliampere or 2 milliampere step, whatever you want. So suppose this is my signal that I want to increase, that is IL1. I want to ramp up with this step of 1 milliampere. You can select either as auto step, or you can uh, click this every time you want to increase the current, and then see whether the relay issues a trip command or not. So once the relay issues trip command, we have to note down that current value at which the relay operated, and that will be the pickup for HV side single phase fault. Similarly, for three phase fault, inject the current in all three phases, and here select IL1, IL2, IL3, and starts increasing the current. And whenever the relay operates, just note down the magnitude of current. Similarly, for MV or LV side, this setting is again same, zero point 0.2 of I base. I have already calculated in the previous slide. This is your zero point 0.2 into 826 or 827. Then your CT ratio is 1600 by 1. So the current in terms of secondary will come out as 103 milliampere. And we have to increase the current from this magnitude to wherever it gives a trip command. Ideally, for three phase fault, it should issue a trip command at 103 milliampere with operating time instantaneous. Now, the next thing is how to check the operating characteristic. There are two methods using which you can check the operating characteristic of differential relay using Omicron Relay Test Kit. First, if you have Omicron Relay Test Kit, you can directly go to PTL library, that is Protection Testing Library, and or Protection Template Library. From this library, you can directly import this RET670 relay template. Uh, this you have to check the version of your relay. Suppose it is 2.1 or 2.2 or 2.3 or 1.3, any version. You have to select this XREO file corresponding to your relay. And now in this XREO file, enter the relay settings of our relay, and this characteristic will be created in the Omicron relay and relay test kit. And now if you inject anything at this point, or if you select any point over here, relay will issue a trip command. If you select any point in this direction, relay will issue a blocking command, or relay will not issue any trip command. So if you see here, this is the minimum pickup. From here, this is the first slope, and then from here, this is the second slope. This is the amount of current from above which the relay will operate unconditionally. That is, it will not see any slope, and it will directly issue a trip command. For this purpose, consider at present this is set as 4.5 times I base. So whenever the current is more than 4.5 times of I base, relay will definitely issue a trip command without looking at any restraining current or slope. Now this is the first slope, and I have already explained in my differential relay session what is the meaning of slope, why we have selected two slope, that is slope 1 and slope 2. So I'm not going into details, but suppose this is slope 1, and suppose this is point 2, this is slope 2, which is point 4, and suppose my slope 1 starts as at 1 of I base and terminates at 3 of I base. That means the end section 1 is the starting point of slope 1, and section 2 is basically the end point of slope 1 and also the starting point of slope 2. So now we have to check that whether my relay is operating at this slope or not, and similarly I have to check this second slope. So now how I can do it manually, this is very important. So for that matter, suppose my end section and section 1 is 1 times of I base, and section 2 is suppose 3 times I base. So sorry, second is 3 times of I base. Then suppose the slope 1 that I have to verify is suppose zero point 0.2, and slope 2 again you have to verify the slope, suppose 0.4. So now how to start the testing? First of all, I already know that what is my I base. I base for HV and LV is respectively 455 ampere and 826 ampere. In terms of secondary, I base in terms of secondary will be 455 milliampere and 516 milliampere for 1000 by 1 and 1600 by 160 ratio respectively. So end section 1 is basically 1 times of I base. So my end section 1 will start at end section 1. It is 1 time, so that means it is exactly the 455 milliampere and 516 milliampere. And section 2 will start at 3. So I have something like this. This is my differential relay characteristic. This is end section 1 and this is end section 2. So from 1 to 3, that is end section 1, this is 1 and this is 3. My slope is 0.2. So if I select any point, suppose I select a point at this 2 times I base. So what now I have to do is I will inject the current 2 times I base on HV side as well as 2 times I base on LV side. So suppose the for LV side and HV side is 2 times means 910 milliampere, 910 milliampere, 910 milliampere. So this is your IHV of R phase, Y phase, and V phase. This is at angle 0 degree, minus 120 degree, and plus 120 degree. Similarly, for the second side, that is LV side, this will be 1032 milliampere at an angle 180 degree, 1032 milliampere at an angle 60 degree, and 1032 at an angle your 300 degree. If I inject this current, since this current is balanced on both sides, so relay will issue no trip up to this point. Now what I have to do is increase the current on any one side. Suppose I'm increasing the current on this side and simple ramp up. So what I have to do is I will simply select here IL123 and I will start ramping up the current of any one side. So once I have started increasing the current, at some magnitude of current, definitely my relay will issue a trip command. So stop the injection and at that point, note down the differential current and restraining current magnitude from the relay. So suppose this is X1 and Y1. Now again, this make the current balance. That is again inject the same current, this, and at this point of time, this was your step 1. In step 2, start reducing the current of any one side. Again, relay will issue a trip command at some magnitude of current. Now again, note down this differential and restraining magnitude of current. Suppose this is X2, Y2, and we know that this is your I restraining and this is your I differential. And since the slope is equals to your I differential by I restraining, so what is the meaning of this I differential by restraining slope means? Now if you calculate X2 minus X1 by Y2 minus Y1, so this must comes out to be in the range of 0.2. If it comes out in the range of 0.2, that means your slope 1 is verified. Now for the verification of slope 2, we know that the slope 2 is something like this. This is my minimum pickup, this is slope 1 and this is slope 2. So what is this point? This is 3, this is 1, and so this is your slope 2.4. And I know that this slope 2 will start from this current magnitude 3 and above. So basically the end section 2 is 3 times I base. So what I have to do simply is I will inject a current, suppose 4 times of I base on HV side as well as LV side, and this will be suppose 4 times of 455 at an angle of 0 degree, 4 times 455 at an angle minus 120 degree, 4 times 445 at an angle plus 120 degree. Similarly, 4 times of 516, 4 times of 516, 4 times of 516 at an angle of 180 degree, 60 degree, and 300 degree. This is your HV, this is LV, and this is similarly RY, the phase of both sides. At this point, the relay should remain stable. And now increase the current of any one side. And when the relay issues trip command, note down the I differential and I restraining. Similarly, reduce the current of any one side And when the relay issues trip command, note down the I differential and I restraining. And with this difference of I differential 2 minus I differential 1 divided by I restraining 2 by I restraining 1, we will get the slope. And this slope must comes out to be in the range of zero point 0.4. If it comes at 0.4 or 0.41, 0.39, that means your slope 2 is verified. So by this method, you can verify the slope of section 1. Slope of section 2, we have already seen how to check the minimum pickup. We have already seen how to check for your differential stability. So up to this point, most of the factors are already covered. The next thing is how to check the harmonics blocking. So for the harmonics blocking, let us look at the settings. So if you see in this particular relay, this is one setting which is I2 by I1, and the next setting is I5 by I1. I2 by I1 is basically second harmonics, and I5 by I1 is fifth harmonics. Now, if you see here, the settings for second harmonics is 10% and settings for fifth harmonic is 25%. What does it means? It means that if in the current, the content of second harmonics is more than 10%, the relay will not issue a trip command and it will simply block. Similarly, if the content of fifth harmonic is more than 25%, then the relay will not issue a trip command, it will simply block. Now, how to check this differential and relay blocking through second harmonics and fifth harmonics? So for the second harmonics, we know that what is second harmonics? Basically, second harmonics means the frequency in the multiple of second multiple of 50 hertz. That means 100 hertz signals. So you have one signal which is 100 hertz, and the content of this signal, if it is more than 10% of the total load current, then relay will issue a block command. So what we have to do, suppose this is my relay test kit. This is current channels. Suppose this is channel A, channel B, and this is my relay. So what I have to do is basically, suppose this is RYB neutral, and this is again RYB neutral. First make these two parallel at relay terminal, kit terminal itself. Now take one wire for R phase, one wire for Y phase, one wire for B phase, and one wire for neutral. So this is your RYB neutral. And now once you have connected this RYB neutral, what you have to do is simply inject the current from this, suppose HV side I am injecting. So suppose HV side current, I know that 455 milliampere is the rated current. So what I have to do is inject a two current, that is IR, IY, IB, and then suppose this is IR1, IY1, and IB1. Suppose this I am injecting as 455, 455, 455. Remember it is in milliampere, so you have to put it dot over here. This is suppose 0 degree minus 120 degree plus 120 degree. Then inject current which is more than 10%, suppose 20%, that is 91 at an angle again 0 degree, 91 at an angle minus 120 degree, and 91 at an angle 120 degree. Since you are testing for the second harmonic, so if this is your 50 hertz signal, so what you have to do is in this side make it as 100 hertz. This is also 100 hertz, and this is also 100 hertz. Now if I inject this current, the relay will not issue a trip command and it will block. So now start reducing this current from 91 to start reducing. It will come down. Once it come down below 45, the relay will issue trip command, because now the content of the second harmonic is less than 10% of the current from the normal current, that is IR, IY, IB. So if you see here how to do this, if you see this, this is the first set of current. This is 455 at an angle 0 minus 120 at a 50 hertz signal. So you have to inject here 91, or for that matter any value which is more than 10%. Suppose it is 80, 80, 80, and this you have to make 100 hertz. Now start injecting. The relay will not issue any trip command. It will simply block, and this blocking is your second harmonics blocking. Once you start reducing this current, and the current reaches suppose less than 45. Why 45? Because it is now, if it is less than 45, that means it is now less than 10% of this rated current. So now the relay will issue trip command. Similarly, for fifth harmonics, if you see here, what is the settings for fifth harmonics? My settings for fifth harmonics is 25%. So now, for testing of the fifth harmonic, there are two different things. One thing is, for fifth harmonics, I know that for fifth harmonics, your frequency will be 250 hertz. So first of all, you have to inject a signal of 250 hertz frequency, and the current magnitude must be more than 25%. That means, suppose I select 30% of 455, that means in the range of suppose 135 milliampere. So what I have to do is I will inject here, I will inject 455, 455, 455 for this. Then I will inject here 135 in RYB phase. This will be 135, and this will be my 250 hertz signal. This is 250 hertz signal. At this point, the relay should not issue any trip command. It will block. Then I will start reducing the current, and once it reaches below 25% of this magnitude, then relay will automatically issue a trip command. So in this way, you can check for the second harmonics and fifth harmonics. Now, the another important thing, if you see here, it is the cross blocking is enabled. What is the meaning of cross blocking and how we can check? Cross blocking means if there is a difference harmonics in R phase, then relay will issue a blocking of Y phase and B phase also. So during the checking of second harmonics and fifth harmonics, inject this second harmonics current in R phase only. Automatically, the relay will block for Y phase and B phase also. Similarly, for fifth harmonics, inject the current in any one phase, suppose Y phase, relay will issue a blocking to R phase and B phase also. So this is the method of testing the harmonic blocking. If you see here, the same thing I have written on. So for this testing, inject the full load current as per the calculation. For our case, it is 455 milliampere. Plus inject 10% of the full load current with set frequency of 100 hertz. The relay will not issue any trip command. If you inject the current which is less than 10% of the full load current, then the relay will definitely issue a trip command. And this is what I have already explained in the previous slide. Now, for the fifth harmonics, what we have to do, inject the full load current as per calculation, and then inject more than 25%. Why more than 25%? Again, because the setting over here is 25. That's why I have to inject more than 25%. And once I inject more than 25% at a frequency of 250 hertz, why 250? Because it is fifth harmonics, so 5 into 50, that is 250, the relay will issue no tripping command. Now, if I inject the current at 250 hertz, which is less than 25% of the full load current, then relay will issue a trip command. In this way, you can check how to do this harmonic blocking testing using Omicron Relay Test Kit. And since I have explained here the procedure for RET670, but the similar procedure is applicable for testing of any other make relays. The harmonic blocking testing, the stability testing, swap testing, everything will remain the same. Only there will be slight changes as per the settings of different make of relays, but the testing procedure will remain the same for each and every relay. I hope the concept explained in this particular session uh, will be beneficial to you, and if you apply these concepts during the relay testing using Omicron Relay Test Kit, and hopefully you will be able to carry out the testing of differential relays by yourself. So I will keep this session only up to this point, and once again thank you. And if you like this video session, then you may share this content with your friends so that they will also get benefited from this content. Thank you again.